All right, we are towards the end of this unit, and now you guys are going to be mad. I get to teach you the shortcut. Yes, there is a shortcut to electron configuration. I can't even say the word. And so a lot of you are gonna be like, why didn't you teach us this in the beginning? And the reason why is because you wouldn't even realize this is a shortcut without learning the long way. It's important to know both because you can't use the shortcut for our atom drawings, but you can do it for just simple electron configuration. So anyways, it's called the noble gas notation. Okay, and so this is again a shortcut for just electron configuration. If I do ask you to draw, you do have to do it the long way. So if you're drawing, long EC is the way you have to do it. Okay, and you'll see why here in a second. Okay, so the name says noble gases. We're going to go into families towards the very end of this unit. So a lot of students, when you guys come to me, you guys know where the noble gases are. So the noble gases, and you want to write this on your periodic table, are the last family noble gases. Okay, it's the last family of the periodic table. And so, like nobility in the old days, they were someone people looked up to. They were like the rich and famous, right? So, noble, that's why the name is here. The reason why is because these elements are where all of our other elements want to be. They want to be like the noble gas, okay, or noble gases in on the periodic table. So, we're going to use them as kind of a starting point for our EC. So what we're going to do is you're going to start your electron configuration for an element at the noble gas before that element. It's very, very simple. You just got to make sure you do the noble gas before that element. So let's go back and do vanadium. So here's vanadium's long hand. Not too long, but it is long. So when I look at my periodic table, here's vanadium. So instead of starting back here with 1s2, if I'm not doing an atom drawing, okay, and I just want to know like where this element is. So I'm going to find the noble gas. Okay, so again, that's this family here. So the noble gas before vanadium, so before was argon. So what you're going to do is you're going to put these like square brackets and you're going to put the noble gas symbol that you're telling the person to start with. Okay, so you're going to say, hey, start with argon. And then from there, then you do your normal electron configuration. So I finished with argon, so I'm coming now to the next thing, which is 4s2. Whoops, be careful there. 3d1, 2, 3. Done. That's it. You're done. I know, I know. So let's say we do borium, which was one of the last ones we did right here, right? This took forever. Like 1s2, 2s2, 2b6, 3s2, 3b6, so on, okay, right? It's huge. So how do we do, let me kind of get back here. How do we do this noble gas? Because I don't want to ever do that again. Okay, so remember here's borium here. It's number 107. So I'm going to find the noble gas that was before borium. So I'm going to swoop back, which was radon, which is Rn. So you're going to put the symbol in there. You got to start from there then. Okay, so here's that. So I finished with radon. And then the next thing is 7s2 triangle coming down to my triangle here. Okay, and then I'm going through, be careful there, 5f14. Then we swoop back up, 6d, 1, 2, 3, 4, 5. Done. So noble gas is a great way to shorten the workload with your noble gases or with your EC. And it's a great way then, once we have the shortcut, it's a great way to do our next and our last learning target, which is figuring out the number of valence electrons. Because y'all, once you have one atom, we can put more than one atom together. We can start bonding. And so bonding is all about valence electrons. Just so you know, I shorthand valence electrons as VEs, okay? And so valence electrons, y'all, are the electrons on the last, okay, or the most outer energy level. So if I'm drawing a quick diagram, 1s2, 2s2, because these, so here's my first energy level, here's the second, this is my last energy level. These guys here are my valence electrons. This atom would have 2 valence electrons because they're the electrons on the last energy level. Can't tell it's an arrow, but it is. Okay, so it's always electrons on the last or the most outer energy level. Now, how I like to do this is I like to do this with noble gas notation because it's like a little shortcut. So let's say we're gonna do, let me erase this right now. There we go. Okay, so let's say we're gonna do potassium, which is K. So potassium, you're gonna like this one. Okay, potassium is right here. So I'm gonna do the noble gas notation. So the last noble gas is argon. I'm gonna put Ar, and then after argon, it's just 4s1. Okay, so what's really nice about noble gas notation is it's going to show you the most outer energy levels, okay? Because it takes away all those inner energy levels. So you're looking for your last or most outer energy level. So my highest energy level that I'm seeing here is just energy level 4. And I'm going to look, how many electrons do I have on there? I only have 1 valence electron. Okay, now if I would have done this longhand, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So here you can see all the energy levels. I have a first energy level, a second energy level, still on the second, a third energy level, still on the third, and the fourth energy level. See how this is the highest or the last outer energy level, and there's only 1 electron there. So you can figure it out from long ways, or you can figure it out from a shorthand way. Okay, let's do arsenic, which is As, which is right here. Okay, so erase this. The last noble gas before arsenic was also argon. And then coming next would be 4s2, 3d, looks like we're going all the way through, 3d10, and then 4p3. So this is interesting because again, I used my shortcut, but we're still looking at the energy levels. So I have a 4, a 3, and a 4. So my highest energy level, my most outer energy level is that 4th energy level. But I have 2 sublevels where electrons are showing up on that 4th energy level. So they are all considered valence electrons. So I just need to make sure I add those up. So 2 plus 3 would tell me that I have 5 valence electrons. Okay, so you're always looking for that most outer energy level. All right, let's do one more. Let's do bromine, which is right here. Again, I'm not going to do zirconium. So again, actually, I do want to do zirconium. I lied to you. I want to do zirconium. I don't know why I'm sounding like this. Okay, where's zirconium at? Cr. Here it is. Okay, so my last noble gas is krypton. And then after krypton, it goes (5s2). Sorry, I lost track of where my arrow was. 5s2, and then 4d2. Okay, so you can see it. That's where I got stuck because like I can't find my element. So 4d2. So 5s2, 4d2. Okay. Again, you're looking for highest energy level. So my choices are 5 or 4. Well, 5 is my highest energy level, and there are 2 electrons on there. So this one has 2 valence electrons. Okay. So that is it. You guys can do bromine on your own, and then we'll check back in together. Have a great day.